Hey guys, welcome to a new video. In today's video, we're going to look at the problem of the day in GeeksForGeeks website. The problem's name is find element occurring once when all other are present thrice. So this question is similar to the Leetcode question, single number 2. So in this question, we are given array integers ARR of length n, where every element inside that appears thrice except for one element which occurs only once. We have to return the element which occurs only once in the output. So in this example, as you can see, 1 appears 3 times. So 1's count is equal to 3 and 10 appears only once. So 10 will be our output because that is the number which we need, as we have to find the number which is appearing only once. In this case, 3 is appearing only once, rest of the elements. So 2 is appearing 3 times, 1 is appearing 3 times and 34 is appearing 3 times. Only 3 is appearing once, so that is the output. And it is mentioned that the expected time complexity is O of n and the space complexity is O of 1. So we shouldn't use any extra space to solve this question. So let's look at first approach which comes to our mind, which has space complexity of O of n. So we are going to count the frequency of every element inside the map and store it in the hash map. And we'll iterate through the hash map and check which element is appearing only once, and that will be our output. So let's take a look at the code. So first I'm creating a map. So I create a hash map here. Now I'll iterate through the input array ARR. So this is the input array. Let's take the first example. So we iterate through the input array 1, 10, 1, 1, 1 from the starting. So I is pointing here. We check if that element is present inside the map. No. So this block will be executed. So we put that element and set its frequency to 1. So 1 will be added and its count is 1. Now let's go for the next element. It is 10. Check if it is present inside the map. No, it's not present. So this will be executed. So enter 10 and set its frequency to 1. Next iteration, I is pointing at 1. Num is 1. Check if it is present inside the map. Yes, it is present. So get its current frequency. Current frequency of 1 is 1. So 1 plus 1 equal to 2. So 2 will be inserted into the value of 1. Now go to the next element. Next element, I is pointing at 1. Check if that element is present inside the map. Yes, 1 is present. Get its current count. Current count is 2. 2 plus 1. So 3. So insert 1's value as 3. And we reach the end of the iteration. In the next iteration, I will go out of bounds. Now we iterate through the entries inside the map from top to down. There are 2 entries inside the map. We take the first entry. So I use entry interface and use this entry object to iterate through the map. Check this entry. I'll get its value. Check if its value is equal to 1. No. If it is not, then go to the next entry. The next entry is 2. Get its value. Value is 1. Check if it is equal to 1. Yes, it is equal to 1. So get its key. So this is the key. And store it inside result. And we finished all the entries inside the map. We come out of the for loop and return whatever is present inside result. Result has the value 10. So 10 will be returned as the output. So in this case, the time complexity is O of n, which is fine, but the space complexity is O of n, but we are expected to solve it using O of 1 space complexity. So let's take a look at the second approach. So let's take this example. Now that we can't use any extra space, we have to find the solution in place. In this case, 1 is appearing 3 times, 2 is appearing 1 time, and 3 is appearing 3 times. Expected output. So this is not very common to get into your mind that we have to use bit manipulation to solve this question. In the previous question, single number, every element was appearing twice. So if you do XOR of every 2 elements, it will get cancelled and the single element will be returned as the output. But in this case, every element is appearing 3 times. So we cannot do XOR operation because there are odd number of occurrences. Now we have to convert these array elements into their binary format. So 1 is represented as, the 8421 code, right? So this all will be zeros and wherever you need the sum, this will be 1. 2 will be represented as 0, 0, 1, 0 and 3 will be represented as 0, 0, 1, 1 because 2 plus 1 is 3. So these 2 bits will be set. And now we know the count of 1. So 1 is appearing 3 times. So let's write this 3 times. 2 is appearing 1 time. So let's write this once. And 3 is appearing 3 times. So let's write this 3 times. And now this is the 0th bit, this is the first bit, this is the second bit, and this is the third bit, and so on. There will be 32 bits for an integer, right? All the rest of them will be zeros. So this will be 0 for everything. So this is 1, this is 2, and this is 3. Now we need to take the sum of every bit. So this will give you 1 plus 1 plus 1 1 plus 1 plus 1, this is 6. This will give you 4, this will give you 0, and this will give you 0. And all the 32nd column will also be 0, rest of all will be zeros. Now if we take these digits should be a multiple of 3, right? So if you mod 3, you should get 0. So the 0th bit is 0, and for this, if you do 4 mod 3, you get 1, which is not equal to 0. So this is the observation which will help us solve the question, and rest of all are zeros. So 0 mod 3 is 0, and this is our output, right? We are doing mod 3 because every number should occur 3 times. That is why we are doing mod 3. But which number is appearing only one time, which is our output? 2 is appearing only once. That bit's digit will not be divisible by 3. So here you can see 4. So 3 are coming from this 3, plus 1 is coming from this 2, and this 3 plus 3 plus 0, this is coming from 1, this is coming from 3, and this is coming from 2. So it means that the 0th bit in 2 is having value 0. So with this we can find out 0. This 1 is coming from the number 2, so this will be 1. So with this we can form our output, which is 2. So 2 is 1 0, and 1 0, which is equal to 2, will be our output. So to check which bit is set to 1 or 0, we can use a mask. So using the left shift operator with the mask, so mask is equal to 1 left shift of the I. So I will range from the bits, that is the length of 0 to 32. So in the beginning, 1 0 will give you some value. 1 shift of 1 will give you the some value. 1 shift of 2 will give you one value, and so on. 1 left shift of 32 will give you some value. So these are the bit positions to know which bit is set or not. So this will give you, so like here we are finding out the mask using a for loop. Now we have to play with these mask values. Now we have to iterate through the number present inside the array ARR. We iterate from starting to end, and we pick the first element in the beginning, and I will reach the end, and this will happen for every element inside that. So we do num and operation of mask. So if this is not giving you 0, if it is giving you value greater than 0, then you increment a variable called sum. This sum is going to be the sum of each bit. In first iteration we get the sum value as 6. Next, with this 6, in the next step after this, we have to check if the sum when modulo by 3 is not giving you 0. With this we will identify the number which is appearing only one time. So this can be written as if sum modulo 3 leaves a remainder of 1, or if sum modulo 3 leaves a remainder of 2, then we build our answer, which is this, which corresponds to this value 2. So answer will be built by doing OR operation with the mask, and this will happen for all the 32 bits, and finally we return our answer. Now let me code it up, and then we'll do the debugging, so that we get the complete understanding of the code. So we're given the input array ARR, and n is the length of that array. We don't need this, we can directly find out. Since we have to return our output, which is an integer variable representing the element which is appearing only once. So let's create it. I'll name it answer, and initially it will be 0. Now we iterate using a for loop with all the bits, that is from 0 to 32. Now we have to find the mask, right? So mask will be 1 left shift of I. And I'll declare this outside the for loop. Now I will iterate through the elements inside the array ARR using a for loop. Now we have to build the sum of every bit, right? The sum operation will be find out for every bit, that is 32 bits. So initially I'll create a variable called sum, and initially it is 0. And now I will build the sum. So if that number and mask is not equal to 0, then we increment sum. So sum is equal to, we'll add 1 to that sum because 0 doesn't have any value. So whenever it is 1, we have to increment it by 1. Like here, as you can see, wherever there is 1, we increment it. So 1, 2, 3, 4, 5, 6. So 6 will be stored inside sum. Now that we have the sum, we have to check if this sum is divisible by 3 or not. Modulo 3 is not equal to 0. So this you can replace by this condition, if sum modulo 3 is equal to 1 or sum modulo 3 is equal to 2. Because for example, if you take any number, so let's take first num is equal to 4. if 4 modulo 3 is equal to 1, because when you divide 4 by 3 you leave a remainder 1. If num is 5 and if you divide it by 3 it leaves a remainder 2, and if you take 6 it leaves a remainder 0. So these are the 3 possible values for reminders, and we are checking if remainder is not equal to 0. So it means remainder is equal to either 1 or 2. So you can replace that with sum modulo 3 is equal to 1, or if sum modulo 3 is equal to 2. Then we build our answer using an OR operator with mask. So answer OR equal to mask. So answer is equal to answer or mask. With that we'll get our final output inside our answer, and outside the for loop you can return answer as the output. So here this is one left shift I, right? And now let's try to run the code. We're getting the expected output. Let's submit the code, and a solution is being accepted. And the time complexity of this approach is O of n, because we are iterating to the array from starting to end. So n is the length of the array ARR, and the space complexity is O of 1, because we are not using any extra space to solve this question. Now let's quickly debug the code. So I've taken this same example and I placed 2 breakpoints. Let's try to debug it. So here mask value is 1. We're iterating to that. Sum will be incremented by 1. Sum will be incremented by 1. Sum is 2. Sum is 3. Sum is 4. Sum is 5. Now the 0th bit is set to 6. We're checking if 6 leaves a remainder 0. No, it doesn't. So that bit is not part of the answer. Correct, right? 0, 1, 0, and 0th bit is 0. This gave a remainder of 6. So that bit is not part of the answer. Now some value is being built for the first bit. Sum value is equal to 4. Sum 4 mod 3 is equal to 1. This condition passes and that bit is being stored as the answer. So we get 4. So 4 mod 3 is 1. In the first bit's position, 2 has the value 1. So now answer's value is being updated by 2. Here as you can see, answer has the value 2. Now it will do for the second bit. And here if you observe, from the second bit to the 32nd bit, 2 has zeros in it. So that won't be part of the final output. So this condition will never pass and final output will remain. As you can see, I'll keep moving forward. I is 3, I is 4, I is 5, I is 6, 7. So this will happen until I equal to 32, because this loop will compulsorily run for 32 times. So as you can see, after 32 we got a final output. So until 32 answer was 2, and finally here, so result has a value 2 and 2 is being printed as the output. That's it guys, thank you for watching and I'll see you in the next video.